right, so we are now going to learn another method of solving quadratic equations, and this is by the method called completing the square. When we complete the square, we are going to be isolating our constant and then creating something called a perfect square trinomial, which we actually have dealt with perfect square trinomials back in our factoring standard when we factored polynomials. Remember, a perfect square trinomial is in the form of ax squared plus 2 times your a times your c, so the square root of your a times the square root of your c, x plus c squared. Now, in number 1, if we are creating a perfect square trinomial, what we do is we take our b value, oops, I don't know what happened there. We take our b value, which in this case is positive 20, we divide by 2, and then we square that number. So a 20 divided by a 2 is a 10 squared is 100. So your c, your constant, would be 100 in this equation here to make it a perfect square trinomial. So let's add that in the notes section. To create a perfect square trinomial, we do b divided by 2, and then we square that. So in number 2, to find c to make this trinomial into a perfect square trinomial, we take our b value, which in this case is 18, we divide by 2, and we square that. An 18 divided by a 2 is a 9 squared is an 81. So c would be 81 to create this perfect square trinomial. Now those two are just warm-up questions. We weren't solving a quadratic equation. Now in number 3, we are going to solve a quadratic equation by completing the square. And so we will be creating perfect square trinomials eventually when we go through doing this problem. So the first step when completing the square is to isolate your constant, which when we're doing the quadratic formula and factoring, we want our constant on the same side as everything else. But in completing the square, this is the only time we're going to isolate our constant. And so now I have an x squared plus a 9x is equal to a negative 15. Now, I'm going to turn that x squared plus 9x into a perfect square trinomial. How I do that is I take my b value, which in this case is 9, I divide by 2, and then I square that number. Well, a 9 divided by a 2 is a 4.5, and a 4.5 squared is a 20.5. So I'm going to add that into my equation. However, in order to keep this equation balanced, if I add it to one side, I need to add it to the other because I cannot change the value of this equation. So in equations, what you do to one side, you must always do to the other side. All right, now on the left, I have a perfect square trinomial. What I'm going to do with this is I'm going to factor this perfect square trinomial, which is something that we did in our last standard. I'm going to take the square root of my first term, the square root of my last term, and the operation that's in between my first and second term, and I square that binomial. That's the perfect square trinomial factored. And then on my other side, I'm going to actually just simplify here. Negative 15 plus a 20.25 gives me a 5.25. Okay. From this step, we are now going to use the square root method, and we're going to take the square root of both sides. The square root of an x plus 4.5 squared, all that does is it cancels out my squared, and I'm left with an x plus a 4.5. And then the square root of 5.25, we're going to need to round, and it does say to round to the nearest hundredth. Remember, when we take the square root when solving quadratic equations, we are going to wind up with the positive version of our number or the negative version of our number, and it's going to be about 2.29. All right, now we're going to isolate x by subtracting 4.5 from both sides. Now I get x is approximately equal to, because I rounded within my work, so it's not going to be an exact answer. But if I do positive 2.29 minus a 4.5, that will get me one of my answers. And if I do a negative 2.29 minus a 4.5, that will give me my other answer. And that is your solution to this quadratic equation. All right, looking at number 4, we are going to start completing the square method. My constant is already isolated, so that's good. So we don't have to do that first step of isolating your constant. Instead, we're going to jump straight into taking my b value, dividing by 2, and squaring that number. A 7 divided by 2 is a 3.5. A 3.5 squared is a 12.25. I need to add that to both sides to keep my equation balanced. Okay, on the left side I factor, so I'm going to take the square root of g squared, which is a g, the square root of a 12.25, which is a 3.5, and the operation that's in between my first and second term, which is a plus sign, and I square this binomial. On the right side of my equation, I actually combine the 144 with the 12.25, and that's a 156.25. Now from here, I'm going to take the square root of both sides. The square root of a g plus 3.5 is just a g plus 3.5. And the square root of 156.25 comes out to be a positive or a negative 12.5. And since that's an exact number, we don't have to put the squiggly equal to sign. We can keep it as a normal equal to sign. Now I'm going to isolate g by subtracting 3.5 from both sides. And when I do that, I get g is equal to, and a positive 12.5 minus a 3.5 is a 9. And a negative 12.5 minus a 3.5 is a negative 16. Now I do want to mention, when you get these whole numbers, when we didn't have to round anything, we could have actually used factoring, the box method or the x method. In this case, it would be the box method to solve this quadratic equation. However, in number 3, when you get a rounded decimal, it is not possible to use factoring, either the box method or the x method, to find our answer. We use the box and x method when we can. And if we can't, we would use or resort to the quadratic formula or completing the square. So I just wanted to make sure that I pointed that out. We're going to continue on with completing the square now. All right. In number 5, we first need to isolate our constant. So I'm going to subtract 19 from both sides. I have an m squared plus a 12m is equal to a negative 19. I'm now going to take my b value, which is 12, divide by 2, and square that number. A 12 divided by a 2 is a 6. A 6 squared is a 36. I'm going to add that 36 to both sides to keep the equation balanced. Now, I factor the left side by taking the square root of my first term, which would be an m, the square root of my last term, which would be a 6, and the operation in between my first and second term, which is a plus sign, and I square that binomial. On the other side, I simplify. A negative 19 plus a 36 is a 17. Now I take the square root of both sides. The square root of an m plus a 6 squared is just an m plus a 6. This will approximately be equal to a positive or a negative, and the square root of 17 rounded to the nearest hundredth is a 4.12. Now I'm going to isolate m by subtracting 6 from both sides, and I wind up with m is approximately equal to a positive 4.12 minus a 6, which is a negative 1.88, and a negative 4.12 minus a 6 gives us a negative 10.12. And these are your two answers for this problem. Since we had to round and do decimals, this would not be a problem that could be factored. We would have needed to resort to either the quadratic formula or completing the square. All right, number 6, my constant is already isolated. However, another important thing when completing the square is your coefficient of your x squared term, or in this case your a squared term, needs to be 1. All right, so let's add that to our notes. I want to make sure that we have that up above. So, in order to get my coefficient of a squared here to be 1, I need to divide every single term by 4. And I need to divide everything by 4 so I don't change the value of my equation. So 4a squared divided by 4 is just an a squared. A minus 8a divided by a 4 is a minus 2. And a 24 divided by a 4 is a 6. Now I can jump into completing the square by taking my b value, which is negative 2, dividing by 2 and squaring that number. A negative 2 divided by a 2 is a negative 1, and negative 1 squared is a positive 1. I'm going to add 1 to both sides. On the left side, I factor. I take the square root of my first term, which is an a, the square root of my last term, which is a 1, and the operation between my first and second term, which is a minus sign, and I square this binomial. On the right side, I just simplify. A 6 plus a 1 is a 7. Taking the square root of both sides, the square root of a minus a 1 squared is an a minus a 1, and this will approximately be equal to a positive or a negative, and the square root of 7 comes out to be, rounded to the nearest hundredth, a 2.65. So now I'm going to add 1 to both sides to isolate a, and I get a is approximately equal to a positive 2.65 plus a 1 is a 3.65, and a negative 2.65 plus a 1 is a negative 1.65. Moving on to number 7, we need to isolate our constant. So I'm going to first add 15 to both sides. I have a 5n squared minus a 3n is equal to a 25. My coefficient of n squared needs to be 1. So I'm going to divide everything by 5. I'm going to show you how to do this one with fractions, just in case you have a problem that requires fractions. So I have n squared minus a 3/5 n is equal to a 5. If you have a thirds or a 6, you need to work with fractions. So now I'm going to take my b value, and instead of dividing by 2, I'm going to multiply by 1/2, which is the same thing, and then I square that number. And now I'm going to have you look at the work for the rest of this problem. Make sure to analyze it. I've got common denominators and all of that.